So good afternoon, everyone. My name is Paril Ghori, and I'm thrilled to welcome you to this session about mastering the machine learning pipeline. And in today's sessions, we will be looking at different scenarios in embedded systems, computer vision, or enterprise AI, where to take the best practices and what to avoid during the ML life cycle. So our today's agenda follows the structural path of machine learning lifecycle. We will cover data ingestion and pre-processing, feature engineering, model selection, hyperparameter tuning, evaluation and validation, monitoring, and at last we will look real-life example of vision case studies where we will see how even the best vision system might fail in real life if we do not track the changes that happens daily. So let's start with ML lifecycle overview. So that's how ML lifecycle looks like from start to finish. And as we can see, it is not a linear, it is like a feedback loop. So think of it as like a living pipeline. We begin by collecting and preparing the data, then we proceed to the model development stage where we do many different feature engineering and data cleaning. Then after that part, we do the deployment, and in that part, we have to maintain different environments conditions, and then we do the monitoring and maintenance. And that doesn't end there. The system needs continuous feedback from each stage, and that feedback is passed on to previous stage, and we need to modify the previous stage based on the feedback given from the next stage. So think of an example which is like a object detection model where we try to detect an object and we try to detect some type of errors in the object, and accuracy might looks good initially few months, but like change in lighting condition, performance might degrade. That is called like concept drift, and that can hinder our accuracy. And without monitoring, once our stellar model become unreliable. And one of the most common pitfalls in this stage is like treating the life cycle as a linear process, not a feedback loop, which can degrade our model in time.